Good morning, students. Today I am going to start part 4 of my video lecture on Unit 10, Haloalkanes and Haloarenes. This is the last part of my video lecture on this unit. In this part, I shall give you solutions to all the questions present in the exercises. I already gave you solutions to all the in-text questions. In this lecture, I shall discuss some selective questions. However, answers to all the questions will be given to you. Question number 10.17. We have to write a structure and IUPAC name and also write whether it is alkyl halide, aryl halide, vinyl halide, etc. and also the nature of the alkyl halide. I have written the answer in bone line formula. The structures have been given in condensed form. I have written the answers in bone line formula. Writing bone line formula is very easy and time saving. It's a smart way of writing the structures. Now question number 10.1, Roman 7. This is the structure. CH3. So this CH3 is this CH3. Then this carbon is this carbon. To this carbon, one is chlorine, one is ethyl. This portion is ethyl. Then CH2, CH3. The longest chain is 1, 2, 3, 4, 5. At 3 position there is one chloro group and one is methyl group. So IUPAC name will be 3-chloro 3-methyl pentane. It is an alkyl halide and a 3-degree alkyl halide. Next 8. CH3 CH double bond C Cl CH2 CH CH3 2. So this CH3 is this CH3, CH is this CH double bond C. This carbon is, then to this carbon attached is chlorine. So this chlorine, then CH2 CH. To that CH there are two methyl groups, this one and this one. The longest chain contains 6 carbons, so it's hexene derivative, and the double bond is present at second position, so it's 2 hexane or hex 2-ene, and in 3 position there is 1 chloro, at 5 position there is 5, so it will be 3-chloro 5-methyl hex 2-ene. It's a vinyl halide. Then CH3 CH double bond CHC PR CH3 2. This CH3 is this one, CH is this one, CH this one, then this carbon and this carbon. Then to this carbon is attached is one bromine, this bromine. Then there are 2 methyl groups attached to this carbon, this methyl group and this methyl group. So the longest carbon chain contains 5 carbons, so it's pentene derivative. And we reach at the double bond at second position. If we come from this side, and then we reach double bond at 3 position. That's why we have to go from left side. So it's a 2 pentene derivative or pen-2-ene. At 4 position there is 1 bromo and there are 1 methyl group. So 4 bromo 4 methyl pen-2-ene. Then P stands for para, Cl C6H4CH2. So here will be 1 benzene ring. To the benzene ring, when the benzene ring is attached to the carbon chain, at para position of benzene ring there is 1 chloro group. Then this CH2 is this one, this CH is this one, then to that CH there are 2 methyl, this one and this one. Should the alkyl chain contain 3 carbons, and in one position there is chlorophenyl group, and two position there is one methyl group. So at one position, this one position is this one. Then in this benzene ring, there is one chlorine, and that chlorine is at 4 position of the chlorine phenyl ring, benzene ring. This is the point of attachment of the benzene ring. So this number will get 1, 2, 3, 4. At 4 position, there is one chloro group. So 4 chlorophenyl, it becomes 4 chlorophenyl. That means at one position of the propane molecule, there is one 4 chlorophenyl group. Then 2 methyl propane. It's an aryl halide. Then M stands for meta, ClCH2, C6H4, CH2, CCH3. Okay, this C6H4 is for benzene ring, and in the benzene ring there is meta ClCH2. So this CH2 is this CH2, then chlorine, it becomes metachloromethyl. Then this carbon is this one, this carbon is this one. To this carbon there are 3 methyl groups, this, and this. Again at one position there is 3 chloromethylphenyl. It becomes 3 chloro because it is the point of attachment of the benzene ring. Then this position becomes second, this position becomes third. So it becomes 3 chloromethyl. This 3 chloromethyl group. This is a 3 chloromethyl group at 3 position of the benzene ring. 3 chloromethyl group at 3 position of the benzene ring. 3 chloromethylphenyl. And then 2 position there are 2 methyl groups. So 2,2-dimethyl propane. It's an alkyl halide and 1 degree alkyl halide, because this chlorine is attached to one alkyl side chain or alkyl group. That's why it becomes alkyl halide. Then O stands for ortho, beer, C6H4. C6H4 is for the benzene ring. Then the benzene ring at ortho position there is one bromine, and this CH is this CH. In that CH, one is CH3. This is the CH3 group. Then CH2 is this one. CH3 is this one. So it becomes so this position. Sorry, this benzene ring is attached at 2 position of this alkyl chain, and this is 2 bromophenyl. 2 bromophenyl at 2 position of the alkyl chain. 2 bromophenyl butane. It's an aryl halide. In question number 10.2, CHF2CBr there are 2 carbons, so it's a derivative of ethane. In these carbons, one is hydrogen, 2 fluorine. So there are 2 fluorines, and in this carbon, one is bromine, one is chlorine, one is fluorine. One is bromine, one fluorine, one chlorine. So the name is 1 bromo, 1 chloro, 1, 2, 2 trifluoroethane. It's an alkyl halide. It's an alkyl halide and 1 degree alkyl halide. For CCl3, 3CCl. So in this carbon, 1 is chlorine and 3 such groups, CCl3 groups. So this carbon is this carbon, then to this carbon 1 is chlorine, and there are 3 CCl3. The longest chain contains 3 carbons, so it's a propane derivative, and at one position and at three position there are three chlorine atoms in each, and in second position there is one chlorine and one trichloromethyl. So 2-trichloromethyl 1,1,1,3,3,3 hexachloropropane. 5. Sorry, this one is again alkyl halide. This is again alkyl halide, and with respect to the second carbon, it is a 3-degree alkyl halide, and with respect to this or this group, it is a 1-degree alkyl halide. 5. Number 5. CH3C PCl2 CHBr CH3. So this CH3 carbon is this one, then this carbon is this carbon. To this carbon 1 is methyl group. So this is the methyl group, and PCl2 two such groups. One is this group and the other is this group. This is parachlorophenyl. Two such parachlorophenyl groups. Then CH, this carbon is this one. To that carbon, one is bromine, one is methyl. So this is bromine and this methyl is this one. So it becomes 2-bromo-3,3-di-4-chlorophenyl-butane. It's an alkyl halide and as well as aryl halide. Number 6. CH33C CH11C Cl6S4IP. So to this carbon there are three methyl groups, this and this, then CH this CH, then Cl this Cl, C6S4 is this, and at the para position of this benzene there is iodine. So the longest chain A 1, 2, 3, 4. Longest chain contains 4 carbons. At one position there is one chlorine. At three position there are two methyl groups, and at one position there is para-iodophenyl or 4-iodophenyl. So it becomes 1-chloro-1. That means this group is present at one position of this alkyl chain. 1-chloro-1, 4-iodophenyl, 3,3-dimethylbutanone. Question number 10.7.3. We have to convert but1 into 1-iodobutane. So hydrobromination reaction in presence of peroxide will give this compound 1-bromobutane. Now when 1-bromobutane is reduced with sodium iodide in acetone, then iodide is going to replace bromide. And this reaction is known as Finkelstein reaction. Then next question is 10.101. These are the products which are obtained by treating this compound with sodium ethoxide in ethanol. So sodium ethoxide is going to abstract a beta proton from this compound. So this compound has three beta positions. Two beta positions. This and this beta position. These two beta positions are same. They're equivalent. So we have to consider only one from this, and second beta position is this one. If ethoxide removes one proton from this position or from this position, then double bond will be here or here. Then this is the compound that is obtained when ethoxide removes a proton from the ring. And this is a more subtle alkene. That's why it is this becomes major compound, major alkene. The other proton that can be removed by sodium ethoxide is from the methyl group. This is also beta position. And the alkene is a less saturated alkene, which is less stable compared to the more saturated alkene. Therefore, it becomes the minor product. Since this is less stable, it will form in lesser amount. Since this is more stable, it will form in larger amount. So it becomes major alkene. It becomes minor alkene. 2. Treatment of this compound with sodium ethoxide in ethanol. So there are several beta positions in this compound. Of course, there are 2 beta positions in this compound. This methyl group and this methyl group, they are same. And this is a second beta position. So when sodium ethoxide removes a proton from this, double bond will form here. So this is the alkene that is formed. And this is more subtle alkene. When sodium ethoxide removes a proton from this methyl group or from this, then this is the alkene that is obtained. So this is again less subtle alkene, this is more subtle alkene. So this is the major alkene, this is minor alkene. Number 3. This compound has beta position, this one, and this one. However, this beta position does not have any hydrogen. So no proton can be abstracted from this beta position. That means alkene cannot be formed, double bond cannot form along these positions. So when sodium ethoxide removes a proton from this beta position, this is the alkene that is formed. When sodium ethoxide removes a proton from this methyl group, then this is the alkene that is formed. So this is major alkene, this is minor alkene because it is more stable, this is less stable. Question number 10.112. How to convert ethane to bromoethane. To ethane on halogenation in presence of light gives ethyl bromide. Ethyl bromide on treatment with potassium hydroxide and ethanol, it gives ethene. Now when ethene is brominated in carbon tetrachloride, addition reactions occurs 1,2-dibromoethane is obtained. When 1,2-dibromoethane is reduced ethanolic potassium hydroxide, there is elimination dehydrobromination reaction. So one hydrogen and bromine will go out and bromoethane will form. Question number 5. Question number 5. How to convert propene to propane. So this is propene bromination in carbon tetrachloride gives 1,2-dibromopropane. Treatment of this 1,2-dibromopropane is a vinyl dihalide. On treatment with ethanolic potassium hydroxide, it gives 1-bromopropene. Now when 1-bromopropene is treated with a very strong base, sodium amide, then there is again the hydrobromination reaction that results in the formation of propane. 10.11. Butane conversion to butene. So 1-butene on hydrobromination reaction gives this compound by following the Markovnikov's rule. When that is treated with again ethanolic potassium hydroxide, it undergoes elimination to form this butane. Question number 10.14. .143. CH3CHBr CH2CH3 plus sodium hydroxide in presence of water gives CH3CHOH CH2CH3 plus sodium bromide. So this bromine is replaced by hydroxy. So this is a substitution reaction, nucleophilic substitution reaction. Alkyl halides when treated with a base where we do not need an alkane to form, we have to use aqueous base, aqueous alkali. So aqueous alkali is going to react with alkyl halide to form alcohol. Number 5. C6H5O, and this is sodium methoxide that is treated with chloroethane. So this is the chlorine is a leaving group. This is a nucleophile. So nucleophile is going to attack the alpha carbon of this chloroethane, and that results in the formation of an ether and formation of sodium chloride. Next, question number 10.19. Toluene to benzyl alcohol. Toluene, when it is allowed to react with halogen in presence of light, it undergoes halogenation in the methyl group to form benzyl chloride. When benzyl chloride is treated with aqueous potassium hydroxide, 10.194. Now, when this benzyl chloride is treated with aqueous potassium hydroxide forms benzyl alcohol. The chlorine is replaced by the hydroxide. 10.20. 10.20. Treatment of alkyl chlorides with aqueous potassium hydroxide leads to the formation of alcohols. When aqueous potassium hydroxide is used, the base hydroxide is solvated by water molecules, for which hydroxide is not able to act as a base. Instead, a water molecule acts as a nucleophile. So when aqueous alkali is used, the hydroxide is solvated by water molecule. Because hydroxide is charged, small charged ion, it is heavily hydrolyzed by water molecules. Therefore, hydroxide cannot act as a base, cannot act as a nucleophile. Instead, a water molecule present in the solvation phase, solvation cell, is going to act as a nucleophile, and that displaces the leaving group. But interestingly, when alcoholic potassium hydroxide is used in reaction with alkyl halide, what happens? The alkali reacts with the alcohol to form alkoxide ion, which is a very strong base compared to the hydroxide ion. The new base alkoxide ion, it abstracts a beta proton with the alkyl halide. That leads to the elimination. In a nutshell, when alkyl halide is treated with alcoholic potassium hydroxide, we get alkene, where elimination reaction occurs. On the other hand, when we react alkyl halide with aqueous potassium hydroxide, alcohol is generated. So this is all about part 4 of this video lecture. I've given all solutions to all these questions. You please go through these answers, study them. If you do not understand, contact me, send me a message in WhatsApp, or you can call me also. Thank you all for your kind attention.